Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Mirdad Abdullahi, the community lead of this great community. Uh, Thank you again for being with us. In the meantime, that I'm doing the introduction, you can just say hi in the chat and let me know where you're connecting from and how's it going from your side, how's the weather, and whatever that you would like to talk about. So, before uh, inviting my great speaker, I would like to just have some quick introduction of what we have, who we are. So today is 26th of session of Fabric Coffee session. Fantastic. In March 8th, and we are at the Microsoft Learn community, and which is at the a tech community, the richest place for learning new things and about Azure and whatever is landing in Microsoft landscape. And of course, there are some learning rooms that you can basically find your experts and your peers in those learning rooms and learn from them and having more closer really actually chat with them and ask your questions and share your knowledge with them. And of course there is a short link in the bottom, aka.ms slash learning room. From there you can just choose the room that works for you, especially for Microsoft Fabric Cafe, which is a community in Microsoft Learn, and we are focusing on Microsoft Fabric, as you can see by its name. And we try to provide learning and support to Fabric users in all levels, and this forum for everyone to learn, share, and grow skills together. In the bottom, I've got the our social links. uh, First of all, on YouTube channel with the handler of Microsoft Fabric Cafe, you can always watch and rewatch the sessions that we're actually completed in the past, and for upcoming sessions. However, for now, you're watching us from YouTube, perhaps, and also LinkedIn. From we've got a LinkedIn link here for our community that we announce all the updates there. And our learning room is join Fabric Cafe in the tiny URL. And also the meetup group. The meetup group, you can always just respond for your availability for each session, and we can just have a better connection, of course. And after each session, you can just rate the session that have been passed, and the QR code is going to land you on our LinkedIn page. Sweet. There's a code of conduct in our community. If you're joining, thank you very much in advance for adhering to these code of conduct. I'm not going to repeat them, but as I know most of you are our weekly attendees. In the past week, actually, it was an awesome week for me because we had our first hybrid session in our community. The in-person session was done in Vancouver, Canada, with lovely attendees. We had a lot of fun. If you missed that, we also had the online, as I said, it was hybrid. If you missed that, just feel free to rewatch it on our YouTube channel, and you will find out how fun it was. And for today, I've got one of our greatest speakers, Brian Bønk, and who is going to talk about the world's fastest medallion load. And let me just invite him to the stage, and we can chat more. Hi, Brian. Welcome
Hello.
back to Microsoft Fabric Cafe. It's great to have you here again.
Yeah, great. It's great to be here. Thanks for having me.
Thank you, thank you. So we're some greeting. Hello from
Oh, from
India.
India. Oh,
Somesh, yeah. Milat HBD
Vancouver.
from Vancouver. Hey, Milat. And we have Chinmay from
Also,
India.
mm,
Also, yeah, Milat. Cool, awesome. Uh, Brian, it was a couple of not a couple of days ago. Actually, it was yesterday that we have received a message from our one of our community members. A question related to real time analytics, and since you're the real time guy, let's call it like this, because most of the sessions that we are seeing from your side, uh, I don't want to say that, but it is what I see most of the time,
mhm.
is talking about real time, and I then answered the question and actually left it there for you. Of course, you're gonna just answer that. I know very well, and I can just answer it, actually ask it now, and also ask it, later. I'm not sure if it is going to be covered in your session, but let's have a look at the question. And if you have, you know, uh, instant answer for this question, feel free to.
Yeah. So eventually, a gold layer with an update policy that tries to do joins in the update policy. Yeah, that is yeah, that is a oh, so you are actually online now, Chinmay. Perfect. That question we can remember that when I talk about update policies, and then we can dive into the whereabouts of this, because I see, Chinmay, you already figured out that you need to put in some policies on the streaming ingestion, because if yeah, but let's create a small cliffhanger here, and see what we can do about this when we hit the update policies area of this session.
And there's another question in the bottom. Secondly, is the support for KQL tables available in Microsoft Purview Data Scan? Or
Oh, I can answer that. Right now, that's a no, but if you make a copy to OneLake, then the Purview can scan those tables.
okay, cool,
I'll also
awesome,
cover how to cover data, how to copy KQL data to OneLake in this session. So perfect.
awesome, awesome. Thank you very much, and thank you, Jimmy, for reaching out. That's great to see the questions. Sometimes I speak in the conferences and sessions. I do like to have questions from from the community. In this way, even speakers can also look for the new solutions, and it is going to just give them a hint at that which issue, what issues the actual developers and in the actual world is happening. And it can be also even a topic to talk about, and for only one session. I'm not sure how agree you are with that statement,
Yeah,
Brian,
sure, yeah, yeah. It
but
it,
yeah.
it 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 depends on the level of depth that you are digging yourself into, right? So you can almost make every teeny tiny topic an hour discussion. So yes,
Yeah, cool. So and cool. Yeah. To me, say I will try copying KQL to one lake.
trying to copy. Yeah, but Chinmay, just hang on in the session, because I'll show you a very easy way to do
Okay,
that.
cool.
So
So and we have two hello from Norway, Oslo.
oh, Joanna. Oh, hello, Joanna. Nice to see you again.
Welcome.
Hi, Norway.
And we have Jahangir also from
Ankara.
Ankara. Hoş geldiniz.
Perfect.
Okay, cool. Yeah. Uh, Brian, hand over to you, and
Yep.
I'm going to
Thank you.
be on the stage with you. And if there's a question, I will bug you. Cool.
Perfect. And thank you. Thank you. Let's get started. Yes, the world's fastest medallion load. I put in unverified at the bottom here because this is, of course, not verified by anyone, only me. But I haven't seen any other ways of doing this faster. So let's see where we end up after today's session. And a small disclaimer here: there is currently a bug in Fabric that is being handled by Microsoft. So when I go into the demo mode, some things might happen unless they made a deployment in the last 2 hours. But I'll talk about that in when we get there. It's not a big thing. It's just there. But before we get started, let me tell you who I am. Excuse me. My name is Brian. I'm a senior principal in a company from Denmark named Intellisure. We do data platform and data strategy work with enterprise organizations all around the world. I'm also a Microsoft Data Platform MVP. If you want to hook up on LinkedIn, then follow the webpage aka.bi/follow. Then that will guide you directly to my LinkedIn profile. I also do a bit of blogging on decode.bi. That will give you all you need to know about real-time intelligence, and I will keep on adding almost every week. I'll add a new post there. And if you need any help on writing your KQL statements, that's the things that you're doing to interact with the real-time intelligence world, then kql.how, a reference guide to the KQL language. I released that 2 or 3 weeks ago. It's currently in beta because there are some things that doesn't work, but that's fine. So if you want to get help on writing your KQL statements, then kql.how is your way to go. If you have any feedback on kql.how, I would love to hear it. In the bottom of every content page, there is a feedback button. If you click yes or no, then you'll be guided directly to the GitHub, and then you can create a ticket for me to read. I would love that. After the session, the slides will be available on aka.bi/slides. That will guide you to my GitHub profile, and you can download the slides from there. Yes, without further ado, if you have any questions during this session, please write them in the chat. And if they are direct questions to me, please start them with a capital Q and then colon. Then I know it's a question. And then also Mirat will know it's a question, and he can forward it to me if I don't see it in the chat. And don't keep your questions till late, because there will also be a time for questions afterwards. But also, if you have questions during this session, just interrupt me, and that's quite fine. Thank you, Joanna, for the comment there. KQL.how, that's the way to go to find your reference guide for custom query language. But today, I'm going to talk about real-time intelligence. Why do we need it? Why is it there? And why do we have such a service to help us? Then I'll also talk about the product family, because it's not only real-time intelligence. It's based on an engine that is used widely across Microsoft. The Fabric experience, what do we have in Fabric? And also demo time. And hopefully that will fly as high as this jet, and also as fast. But let's see how we get there. And last but not least, perspective and patterns. If you have any questions, we can dive into those. Or if you have any things, ideas, things you want to discuss, then we have time for that in the end of this. But let's get started. And as we know it, the world is exploding with data. The data velocity is just doubling every year, at least. Some will say it's even more, but we have high granularity data all over us. High granularity data is data that is coming in constantly in a streaming manner. It could be your phone, your device, that will stream events to a server somewhere. And the more apps you have, the more events it will stream to a server. It can be your smartphone, your smartwatch. It could be your laptop. Every time you click something in Windows or in Office, then that creates a telemetry record, and that telemetry record is streamed to Microsoft servers somewhere in the world. If you have a smart car, a modern car, then that will generate around 1 gigabyte of data for every 5 kilometers, and that is also streamed to somewhere in the world. We have windmills, we have temperature sensors, wind sensors, all over. We have streaming data all over the place, and we need some service to handle that. That service from Microsoft is based on the Custo engine. The Custo engine is built solely by Microsoft. It's a proprietary engine built by Microsoft, and it is built for time series data. So what is time series data? Time series data is a data set that is constantly being streamed. It's constantly generating data sets, and you can look at it as an immutable data set because you don't have to change it. It does not by default contains any errors. So it's immutable. You don't have to update it. It's when that event has happened, we need to store that data somewhere, and we don't need to update it. We need to query it. So yes, Joanna, it could also be your airport. I know, Joanna, you just implemented at your current employer a very, very awesome real-time intelligence solution. And the airport could use this for real-time intelligence to move people around, to see where the airlines are doing, all that kind of stuff. But I'll get back to the use cases in just a second. On top of the Custo engine, Microsoft has built different products. On the left, we have Fabric with real-time intelligence, the event house. In the middle, we have Azure Data Explorer. It's the same service, just in Fabric and in Azure. And if you want to have it locally in a container, then Costain is a thing you can download, and then you can install it in Docker, and then you have a look-alike Azure Data Explorer. It's not a full-blown one, because that will demand you to have a full server rack in your basement. But you can get there and get a feeling of what the Custo engine is. I've gotten questions around, hey, what about the name? Why Custo? Well, you might recognize the name a bit if we translate it into French and then put Jacques in front of it. Then it's Jacques Cousteau, and Jacques Cousteau was known for his dedication to explore the world beneath the seas. And he also invented the current scuba diving equipment that we're still using today. And the founders of the Custo engine are all four of them. They are scuba divers, and they would like to help us explore the ocean of data. So you have a connection there, and perhaps you can give that as at the next family dinner to the one sitting next to you. A funny story. On top of these products, Microsoft is also its own internal client, and it's its own biggest client on the Custo engine. Azure Monitor, Azure Sentinel, Azure Defender, PlayFab, different kind of services and solutions are all built on top of Custo engine. So even though you're not working with real-time intelligence or Azure Data Explorer, if you have touched upon Azure Monitor, Sentinel, Defender, all that kind of stuff, then you have worked with the Custo engine behind the scenes. And I see an attendee from Mongolia. Welcome. So let's focus on the red lightning here and see what is Fabric real-time intelligence. Well, Fabric real-time intelligence is actually a suite within the suite, because Fabric is a suite of services. We have Lakehouse, Lakehouse, Warehouse, pipelines, notebooks, different kinds of services. But Fabric real-time intelligence is not one service that you just start. It's a palette of service that you can choose from. If we start to the left, then we have our sources, which we need to read and digest and implement and store into a solution. To do that, we use event streams. Event streams is live processing of data. When a data set enters the event stream, you can process it with not a limited, but a subset of standardized data wrangling methods, joining, grouping, filtering, those kind of stuff. And then we can save that data to an event house. The event house is your server for your databases. So an event house needs to have a database underneath it, and each event house can have more than one database. So an event house is a server if you are from the SQL world, and then the database is called KQL databases, and you can have one or more in an event house. To the right, we have the Reflex, the data activator object, which can actively listen to your data sets, and based on your configuration, on your thresholds, on your needs, then it can react to that data. And if a KPI goes above a threshold, then it can send you a message on Teams, send you an email. It can start a pipeline or notebook, or it can also start a Power Automate flow. So you have every means to automatically react to your data based on data activator. On the middle here, we have the KQL data query set, which is just a query pane or a way to store your queries from the KQL world. The KQL is Custo Query Language. That's the way you query your data sets. And And if you want to visualize the data, you have two options. You have real-time dashboards, which does not require you to have a Power BI license. It's free of charge. It only consumes the KQL statements behind the scenes, behind every tile. I have videos and statements, blog posts on that if you go to my blog. To the right, of course, we can also add this to Power BI. And all of this is encapsulated in the real-time hub as service from Microsoft Fabric. Of course, OneLake is also a part of the real-time intelligence, but it's a bit different because by standard, the data is stored in the Custo engine, the proprietary database from Fabric, from Microsoft, sorry, and you need to manually add a copy of that into the OneLake. And we had the comment from Chimney, and I will show you how to do that in just a bit. And there was a comment, act or react. Yes, exactly. That is the question. It is react because it cannot act. It needs to be processed somewhere. So I would say it's react, but I think if you talk to Microsoft, they will say act. But it's I don't know. It's a good question. I get that. So use cases for your real-time intelligence. That was what Ivana just said in the comments here. An airport or a windmill. If you are in any windmill around the world, there is around 80 sensors to sensor temperature, wind speed, wind direction, power consumption, power production, all that kind of stuff. And we would like to have that streamed in to see what's going on in our windmill. Can we do predictive maintenance? If a sensor goes haywire, should we do something? Should we send a person out there to handle that? Manufacturing throughput, sensors, bottlenecks. If you have a manufacturing plant, then if a conveyor belt stops, we need to see that. If it's operated by robots, then if a robot stops, then what do we do about that? Race cars is also an option. If you attended Microsoft Ignite in November last year, you would see that there was a real-time stand, a real-time booth with a race car game, where they had 2 seats for attendees to try out. And when people drove that car in virtual, the telemetry from those cars was streamed out through Event Stream to an event house and then to real-time dashboards behind the scenes. So people not driving could look at those 2 screens and see what was the speed of response, the braking power, the steering, all that kind of stuff. Amazing. And of course, an airport. If you are an airport, then you can begin to see what about the airlines? What about our luggage handling? What about our people? Do we need to move people around in order to have a good spread of people in the airport? You can use real-time intelligence to do all of that. So a great deal of use cases here. Another use case I just heard about yesterday was if you have a server that you are maintaining or monitoring, and that server CPU spend or cost peaks at around 99%. You need to know that now. You don't have to wait until the data warehouse has been processed and then you'll see that tomorrow in the report. No, it's highly valuable right now, and you need to know that now, and you need to have a DBA go into that server and figure out what's going on before it's too late. That's also a real-time intelligence use case. With that said, we have the real-time hub and we have real-time intelligence. With those 2 entry points in Fabric, we can begin to digest events from the left side. So if you have events going on and you want to listen to them, you want to store them, you want to process them, then real-time intelligence is the way to go. Events can also be telemetry, logging, whatever streams you do have. On top of that, we can build real-time analytics. We can do real-time dashboards with a continuous update of all the data, so you have a live data set flowing into your reports. We have real-time dashboards. I just touched upon those. Real-time triggers, the data activator. We can now react or act, that's a good question, to the data, and have other things going on behind the scenes. We don't have data engineers or other engineers watching a screen to see a peak in a KPI. We can have that handled automatically. We can also score our data towards an AI engine and have the AI results stored directly in our database live. Real-time application, we have all been exposed to these when we do online shopping. We have basket suggestions. Oh, you bought these 2 books. Perhaps these 5 books are also of interest to you. That is real-time applications, just one example. And of course, we can send these events onwards to other services and have them do what they want to do with that service. But today I will focus on the event house and how to process that. Excuse me for 1 minute. I have something in my throat, sorry. I will focus on the event house and how we can process that data the fastest way possible through the Medallion architecture. What I will show you is not a rule set or a best practice set. It's just I will show you some options, and then you can build your solution based on those options. But the event house is there to store your data and to process it in a near real-time manner. I'm trying to click on the slide here. There you go. I will show you how to handle things with materialized views. A materialized view is, if you are from the SQL Server world, then it's just a pre-computed result of a query that is being stored on disk, always ready for querying. It is faster than a view because when a row enters the underlying tables, then the view is being updated and the result is being stored on disk. We also have the update policies, where we can, when a row enters the source table or more source tables, that update policy can read the data, and the output of that update policy can be stored in the next level. So that's the way to go. So first of all, let's build the bronze layer with using the event stream in Fabric, and build the bronze layer with just a demo data set. And let me find my Fabric installation. That's right here. This is my Fabric. And so let me start with a blank space here. Let me call this Fabric Cafe. And let me make sure that this is on a Fabric capacity and apply that. So now I have a clean slate. I have an empty workspace. And here I will, in order to store my data, I'll get back to that to this item in just a minute. But in order to store my data, I need to have somewhere to store it. So I will start by creating an event house. For demo purposes, I am naming my items what they are to easily be able to find them. You will have your naming conventions. Please use those. This is just a demo, and an event house in my demos are always named event houses. So now I have an event house, and underneath that event house, I have a KQL database called event house, because by default, I get a KQL database with the same name, and I also have a KQL query set. I'll get back to the details in just a minute. But first of all, we need to ingest some data using the event stream. And again, you might guess the name. I will call this event stream because it's just a demo and the item is an event stream. Behind the scenes, while this is proprietary, while this is spinning up, behind an event stream, you have a Azure Streaming Analytics, and you also have an event hub behind the scenes. But this is the same services, but with a UI on top of it. When I start my event stream for the first time, I'm being asked what kind of data do we want to ingest: external data set, sample data, or custom endpoint. External data is everything else than the other two. Sample data is a sample data set from Microsoft. You have 4 options now. They just recently added the 4th one. I'll show you that in just a minute. And the custom endpoint. If you can't read the data directly from your sources, you might be able to send the data to event stream. So if you want to send the data to event stream and not read it from event stream, then you will want to create a custom endpoint, because that will give you API endpoints with secrets and all that kind of stuff to send data to an event hub, and that event hub will automatically be sending the data to event stream. But I will use the sample data set, and I will use the bicycle data set, if I could spell. Bicycles data source demo. And you will see here that I have now 4 options. I have bicycles, which we are using now. It's an artificial a bike shop that rents out bikes. We have the yellow taxi from New York, all the taxi rides. We have a stock market data set, and we have buses. But for this demo, I will use the bicycles and add that. So now I have the source of the data, and my canvas is now being presented to me. So to my left, I have the sources. In the middle, I have the event stream processor, where I can add options of handling my data. I can aggregate it, I can expand it. Expansion is if I have a nested JSON object, I can expand that into columns. I can filter data, I can group it, join it, I can change the data types, column names, all that kind of stuff. But I can also save it. And the data I'm saving is the data set that I see a snapshot of in the bottom. I see that the data format is JSON, and the time range is in the last hour or something. But if I want to see more, I can always change that on my right to have other windows of seeing the data. And this is just a snapshot of the data, and it is not being stored anywhere. It is only being read, and it is being read in a retention that is default there. If I don't save it, then every 24 hours, the 24-hour old data will be deleted. I can change this to whatever days I need. So right now I have 24 hours from I begin to read the data to save it somewhere else, or else it will be lost, the 24-hour old data. But I will add this to an event house. Destination name is just event, it's just a name. Event house bicycles. And the workspace is Fabric Cafe. The event house, I just created that, so that was the event house. This is why I needed to create the event house first. KQL database is the same name. And the destination table, as I just created the event house and the KQL database, I don't have any tables, but I can create one right here. So I can call this bicycles. Bicycles. The bicycles tables is now, the bicycle table is now my bronze table. I'll save it. Now I have designed my event stream, but nothing is being stored yet until I hit the publish button at the top right. So please, when you are done with your event stream, click the publish button. And when that is being published, then you will see that now the source is active. And when the event house bicycles destination has been configured as it up and running, I will also see an active ticker here. And I can now, if I want to, I can disable both the source and or the destination to my needs. But as this is running, I'll go back to the event house and show you what we are going to be working with there. This is my event house. Right now, I don't have any data because we are still waiting for the event stream to start processing all the data. Yeah, that's right. But underneath the event house, I have a KQL database called event house. And this KQL database now has the tables to my right. This is the bicycles tables. I created that from the event stream. And the bicycles table has some columns. I will also see in the middle, I will see that I have already executed some queries. Why is that? I haven't executed any queries yet, but I do have, because the event stream is trying to query your database on, hey, do I have any tables I can connect to? And what are those tables? And also, you will see that I have two queries. So it has executed two queries on, hey, give me all your tables and give me all the columns in that table, but I don't have any. So even though you don't, as a person, have executed any queries, engines will execute queries against your database. To the right, and this is perhaps for Chimney to see, to the right, I have the one-leg availability. This one. If I enable this one, then I will automatically, with a magic wand, I will have a copy of my tables in OneLake. I don't have to do anything. This is a one-click option. And even though you are now storing data twice, you're storing it in the event house and you're storing it in OneLake, you're only paying for that data once. So don't be frightened that, oh no, I have 3 terabytes of data in my event house. Well, you will only have to pay for that once, even though you have a copy of that in OneLake. Microsoft is handling all of that for you. So Now that data, whenever it will come in, it will also be copied out to OneLake. It is not a live copy. It can take some minutes or even half an hour because Microsoft is trying to optimize the Parquet files in OneLake because we don't want a Parquet file with one transaction. We want Parquet files in a matter of 100 150 megabytes, and Microsoft is trying to do that optimization before handing it over to OneLake. Data will still be live in the event house, but the copy to OneLake will have some retention. And now you will see the blue spike just came in. I now have queries. I think I saw 106. Yeah, 106 rows has entered to our bicycle table. I know this is a bicycle table because that's the only table we have. And if we begin to query that, if I use the event house query set, this is just a placeholder for all my queries. Then if you see the bicycles, then you'll see that I now have data in this. So let's see what we can do with this bronze data. But let me first of all get back to my slides and show you what we're going to do. As I said in the first part of this session, then I will show you possibilities. This is not a given architecture or given reference architecture. It's just we have two options, or perhaps more, but I'll show you two options of how to handle data very, very fast in a medallion architecture. And the first option I will show you is update policies. Update policies from bronze to silver is way, way effective because it can read data from one or more tables, and the output of that query can be saved to the next table, so the silver table. And this is perhaps the where the question from Jinmei come into play, where the question was, hey, I can't do joins on update policies when I have when the joining dimension tables also have ingestion properties tied to them. That is 100% correct. You can't have joins to table that also have ingestion policies updated. So if you have tables and the main table is perhaps your fact table, and you want to join tables to that in the process of handing them over to silver, then it can only have one table with the streaming ingestion enabled, and the other tables, the slave tables, needs to have them disabled. That's just the way the engine works. If you want to have more joins on streaming enabled tables, use a materialized view. It will give you more or less the same output, but you have pros and cons on them. So go to a materialized view if you have tables with streaming options to them. Materialized views is a part of the next part of the session, so hang tight and I'll show you how to do that. But let's see what we can do with update policies, and this is live demo, and I know there is a bug, so let's see how far we can go. I have cheated a bit, and I need to find my notepad. If I can find it, it's there. So I cheated a bit, and this is my queries. But first of all, if you haven't played around with Kusto query language before, then go to kql.how and learn it there, or follow along in the next 2 minutes. I'll give you a hack. That hack is that you can actually write SQL. Select top 10 from bicycles. This works. It will give you the output that you expect. And if I can even filter that, where a bike point ID equals, let me say this one. Execute. 2 rows, perfect. I now have data. And when I'm done with my SQL statement, I can get this translated into Kusto by writing explain just on top of it and execute all 3 lines. And the output is no longer the dataset, but the Kusto query that I can copy out and begin to compare and learn how to write a Kusto query. You will also see that no one likes the star here, not even the Kusto engine. So that is being translated to the project operator, which is just a column selector, and then it selects all the columns that you are asking for. If I don't want number of bikes and bike dogs, and perhaps I don't want the neighborhood, I can just delete those, and then I will only get the 4 columns asked for. But let's get started with the update policy. In order for me to show you how fast this is, I will enable the ingestion time. The ingestion time is a hidden feature on all tables where I can see down to the last millisecond when that row was entered in the table. So I will alter the table of bicycles, and I will enable the ingestion time to be true. So now I can begin to query the ingestion time of the table. So if I click the table, you will see to my right that I now have the ingestion time visible, and I can begin to see when that data was entered. Also on older rows before I enable it, because it is always there. I just need to enable to be able to query it. But there's a catch here, because if I just query the bicycles table, I don't get the ingestion time. I need to project that, or sorry, extend that to if there. The hidden column is called ingestion time, and you will see to your right now that the ingestion time has a small $sign because it's a system handled column, and you can't manipulate with this. You can only read it. But if I want to rename this to bronze load to table, then I can just do that, and then it will be renamed to bronze load to table. So let's use this query to create the update policy. So an update policy is based on a query and a table. Actually, two tables, but I'll get back to that. An update policy is just a function. I'll create a function, and the function is from SQL just a store procedure. Oh, sorry, that was a question. However, materialized views expect a summarize operator at the end, which won't be the case always in case of fact tables. Well, not always. You can actually create materialized views just as a select statement. You don't need a summarize. But you can also just summarize on all columns if you really want to summarize. But you don't have to use a summarize. But there's a hack there. I don't have time to show you. But Chimney, if you reach out on LinkedIn, I will happily help you later on. Good question though. But okay, functions / store procedures. A function in Custo is just a store procedure in SQL. It's the same thing. It accepts variables and it outputs data in a data set. So this data set, the ingestion date, is just when did we ingest this data to our bronze table. And then I'm creating this. So I'm creating a function if it does not exist and then I like to document the things I'm doing, add ingestion date time to raw data, and I'm calling this function pass bicycles. So if I run this, it will create a function for me, and that function is now available to my left in the functions pane, and I can see here pass bicycles. And I can now use pass bicycles as I would in any other query, and I can begin to query that table or object. And now I have the ingestion date as a column, which is the actual ingestion date from that specific row to this table. And in order for me to create an update policy, I also need a destination table, so the silver bicycle table, the silver table. And I can do that by create a table called silver bicycles. I'll put in a plural here. And then I need to write the columns. And the columns is these. So bike point ID, that's a string. And I also need to add street, which is a string. But this is cumbersome. I don't want to write these columns every time. So there is this. Let me give you this hack. If I do this, then set or append to silver bicycle by spell bicycles, and then I want to use the pass bicycle function. So set or append is a command in Custo where you create an object based on another object, or I append data to that object. So set or append, I can also just use set if I want that. Set gives me the same thing. Set, so create an object. This is the same as select into, but create an object called silver bicycles based on, that's this command, pass bicycles. And then I'm just taking 0 rows, because if I execute only these two, I don't get any data. I just get the metadata of this output. So if I create a silver bicycles based on this query, then I now get the silver bicycles table. And that table has all the columns and the ingestion data created for me. Without further ado, this is way easier than typing in all the columns here. So it's up to you how you want to do that. So now I have the bronze data ready, and I have the silver table also ready to accept data. And I want the ingestion time for this demo to be enabled on this table, because then I can begin to compare the data between bronze and silver. Now I am, there you go. Yes. Now I'm ready to create my update policy. An update policy connects to the destination table, in this case, the silver tables. So I'm altering this table, and I'm adding a policy update. So an update policy. An update policy has some descriptive parameters. It has a source, which is the source table. It has a query, and this also answers why I only can have one streaming table in an update policy, because the update policy listens to the signal from each table, from the source table, and when a row enters that table, it executes this. So imagine I have 10, perhaps, no, let me do it simple. Perhaps I have 2 tables in an update policy, and the rows enter that table simultaneously. So when do I execute this? When are we done? When can I execute this? So you need to only have one table as the source with ingestion policies enabled. So the source is the bicycles. The query is the past bicycles. That's the function I just created. I want to enable it. Of course, I want to do that. And then there's an option of is transactional equal to, is transactional equal true. Transactions in Custo is the same as in SQL. If one row is in a transaction has an error, then all the rows in that transaction is discarded. If it is non-transactional, then if one row is errored, then is only that row is discarded, and the other rows are just being added to the table or in the transaction, whatever you are doing. So that's it. Now I've created an update policy. I have created a full ETL process. I have data in bronze. I've created my silver table, and I just created an update policy with this one line of code. Am I cheating in this one line of code? Because you might argue that I could put this in 4 lines of code, but then you will get an error in Custo. So this has to be in 1 line of code. So in this 1 line of code, I've created a full ETL process from bronze to silver. And while this is running, perhaps it is not having any data yet. Let's see. Because this is dependent on when data enters the bronze table. Only when data enters the bronze table, the silver table will begin to get data. So let me go back while I am talking to my slides. And come on, switch slides. There you go. So now we have the bronze table, and we have created an update policy, and we have data coming into the silver table as I speak. The next option, and again, this is only, I'm giving you options, so you are the ones who build this Lego set to whatever you need. The next thing I will show you is materialized view. The materialized view I will be using for the gold layer, and the materialized view is just a query that is always being executed when data comes into the source tables, and the data is then being stored in not a table, but on disk for you to query when you want it. That's a materialized view. So let me go back to this and see if we have data now. Yes, we have data. And now we see the bug I told you about in the beginning. Look right there. This is empty. I would expect to have dates here, but I don't. Even though the past bicycles has data, it was these data I was expecting to have in this table. That's empty. That's a bug. It is reported to Microsoft. They're looking into it, but just know that when this works, then you will have ingestion data. This is a bronze date, would be available to us. And I could also extend and look at the ingestion time. Then I would have 2 dates, and then I could begin to compare those. But let's do the comparison manually. Let me just let me do a quick query. Bytecode ID equals. Then I will find one manually, and then we can begin to compare. what how fast we actually are. I'll just take this one. And you will quite quickly see that if you are used to SQL, then Custo is not that far from it. Excuse me. The only thing you need to remember is you have two equal signs and not only one. Oops. Equals 10. Oops. Sorry. That's it, sorry. And number of empty dogs equals 14. This gives me 4 rows. And let's put in the past bicycles instead. Oops. This is now the 6 rows I have. And let me take the last 2 ones. Let me take the timestamps from this one. And let me put it there. This is the timestamps from the bronze. Oops, bronze. And let us see what we have in the silver if I do the same thing. Silver spell, sorry, silver bicycles. And I want the ingestion date, ingestion time, and I want all of that. This one. Let me put that there. And then I should have more up here. I do. So that one goes there, and let me delete that one. So there you go. And this one I need that timestamp also. So let's zoom in a bit and see what we have here. This is silver. Silver. Let's zoom in here and see what we have. This is the bronze entry into the silver, and this is, sorry, I moved these around. This needs to be silver, and this needs to be bronze. Sorry for that one. So zoom in a bit here. So bronze, I have a timestamp of something 47 12 23. In silver, the exact same second, but 48 10 86. In bronze, for the next row, 86 91 and 86 99. We are talking about a maximum of 2 to 3 milliseconds between bronze and silver. Imagine doing this in a pipeline or in a notebook. That is not going to happen because the pipeline and notebook are still trying to find a way to start a cluster and execute what they want you to do. The update policy just works. When a row enters the bronze, it is almost immediately available in silver. Quite amazing. And from here to there, from bronze to silver, we are talking perhaps 1 to 2 milliseconds in this demo. If you have larger data sets, it might take a bit longer, but a bit is perhaps 1 or 2 milliseconds more. So update policies 1 to 2 milliseconds between the data sets, quite amazing. And let's create a materialized view and see what we can do with the goat layer. A materialized view is just a query where I can begin to do stuff with it. The materialized view is just a query, and I need to add that as a name, and I need to add it to a source table. So this is the thing that I would like to do. Summarize operator. What is happening by the bicycles? It's in plural. And then this is with a small p. This is the output I want, and then I can create a materialized view based on top of this. Come on, I need to add this there. Sorry for that one. Execute. So now I have a gold layer. I don't need to do anything. This materialized view will always be updated. And there was a question, how the load times work at scale. It will work because Fabric Event House, the real-time intelligence and the Event House has an auto scale property. Let me go back into the event house and let me click the minimum consumption. You will find the minimum consumption at the top here. Oh, sorry, with a small clock on it. If I click that one, you will see to the right that I have options of what kind of size of my event house do I need. On demand, then Microsoft is scaling your event house based on needs. But if you want to have a guaranteed consumption and a guaranteed speed at any point in time, you can select other consumption levels here. And extra large gives you three dedicated nodes in one cluster, and each node has 132 gigabytes of data of memory, and it has, I don't know, unlimited storage. It has enough for you, trust me. It also costs you 50 capacity units. So, sorry. If you have a 64 and F64, you only have 14 capacity units left when you start this one. But it will scale and it will handle the data for you. If you are ingesting more than, I think it's 1 million rows per second, then you might see a bit latency here, but then we're talking about 4 to 5 milliseconds maximum. So it will scale, it will handle the data for you, and don't be frightened. It will serve its purpose to you. But back to the event house and back to the materialized views. This is the materialized view. It is now created for me, and I can find it here. You will see the small lightning here, because that is always materialized, and I can just execute a query against this, and I can use that whenever I want. There's a small catch. If you want to change the ingestion batching, you can do that on a maximum operators. You have maximum batching time span. So what's the maximum time that has to run before I update my objects, or number of items, or row size in megabytes? I don't have a minimum, so I can't restrain it. I can only say, hey, at least when I have 10 seconds, do something. Not every second do something, but at least every 10 seconds do something. So that's it. Now we have data in our materialized view, and we are ready to process that onwards. That was the demo. There you go. And we're ready to process that onwards in a real-time dashboard or wherever we are in the world. Also Power BI. And this is sub 1 second. I guarantee you, whatever you do, whatever data set you have, if you do it as I just showed you, you will have this in at least, in maximum of 1 second, you will have from bronze to gold, and also in the real-time dashboards. If you want to learn more about update policy, I did a blog, decode.bi/blog/update policies, where you can read all about update policies. And I think my time is up in 2 minutes. The last slide from me is just a big thank you for the questions and the comments. I hope I answered the 2 questions during this session, if you listened up. If you're social and want to follow along on LinkedIn, scan this QR code, and that will guide you directly to my LinkedIn profile. Thank you.
That was awesome, Brian. Yeah, that was really interesting. Less than 1 second, you can have your, medallion architecture. That is, that's fantastic. If we can have our basically. Let me just stop this guy. Have it in production. That would be awesome. That's awesome. As you say, it is working at scale, and yeah, awesome. Guys, any question for Brian? If not, I'm going to just share my slide again. So today's session with Brian is done. Thanks so much. We've learned a lot. I'm sure people on the call also we're enjoying. So if you missed that, of course it is going to be, if you joined late, you can of course rewatch it on our YouTube channel. It will be available immediately. And just bear with us with the our two other sessions in March with Andy and Santosh. And again, our social on YouTube channel, LinkedIn, Learning Room, and Meetup. And just don't forget to rate the session on Meetup. That means a lot to us. And Brian, that was fantastic. And I do appreciate your presence and sharing your knowledge with the community. It is
Sure.
really, a great thing to have. I know for me, at least, and I'm sure people love to hear from you more, and of course we're going to have you on our cafe. So there are two questions are coming to the chat if you still have time and
Sure.
be with us. Chimay is asking how to find out which all update policies are applied on a particular table.
Oh, good idea. There is a meta query dot show table update policies, and then give the table name, and then you will see all update policies assigned to that table or that uses that table as a source. So there's a metadata query for that. Jimmy. So
Okay.
just look it up on kql.how and you will have a guide right there to find it.
And another question from Don. Compared to other streaming technologies such as
Mhm.
Kafka, Kinesis, what are the advantages of Fabric real time?
The advantages of Fabric real-time intelligence is that this is it's a consolidated service that gives you everything you need to know about or everything you need to have around data and analytics. Kafka and Kinesis is a very narrow specific service that gives you only streaming and only real time. And when that is up and running, that's quite fine. But you can then stream your data from Kafka directly to Fabric real time and process your data and analytical parts, what you need there. So Fabric is built from Microsoft as a service to handle your analytical needs. It is not built to handle all your streaming data. Fabric real-time intelligence is, as it says, intelligence. So it is built to do analytics based on top of your real-time data, whereas Kafka is built to handle your streams in your data mesh, something between entities, right? So it's two different services, two different purposes, and I do think that if you join Kafka Kinesis and Fabric, you will have the best of both worlds.
100%. And Sam just said
Sure,
thank
Sam.
you.
Thank
Great
you.
session. Thank you for joining, everybody. If there is no more question, we can wrap up the session. And for sure, Brian is a community guy, and I am sure on LinkedIn, if you ping him, he's going to answer the question.
Sure.
But thank you very much for being with us again, Brian. And if you want to add something, and before we wrap up, feel free to add it. If not, we can just hope wishing a good event for sorry, weekend for everybody around the world. Yeah.
Yeah. Have a great weekend and thank you for having me, Medan. And again, if anyone has a question, ping me on LinkedIn. I'll happily help you. Sure.
Awesome. Thank you very much. And guys, enjoy your weekend, and just let us know if you know have any question. You don't have to wait until the day of the session. You can just always send your questions, and we will bring them up to our speakers' attention, and to have a better interactive one. Milad, stay safe, everyone, for sure. And Michael, thank you for joining. Cool. Have a good one, and cheers.